Hey everyone, welcome back to the College Algebra playlist. If you've made it this far in the playlist, congrats. All right, you just made it through all of the factoring content. We had 5 whole videos on factoring. All right, so in this video, I want to move to a different topic. Okay, in this video, we'll be talking about rational expressions. All right, and we'll show how to simplify them, and we'll also show how to multiply and divide rational expressions. All right, so let's get started. Okay, here we go. Simplifying rational expressions. The first thing we need to do is define what a rational expression is. All right? The quotient of two polynomial expressions is called a rational expression. All right? So here's an example of a rational expression. Right? We have a trinomial up top and we have a trinomial on the bottom. All right? And it turns out that that's a requirement for rational expressions, all right? There have to be variables in the denominator, all right? So if we had, for example, x squared plus 8x plus 16 over some number like 4, that would not be a rational expression, all right? If there's only constants in the denominator, that doesn't count, all right? There has to be variables in the denominator for it to be a rational expression, all right? And this will become important when we talk about solving rational equations. All right, but for now, we're just going to define rational expressions themselves and simplify. All right, simplify the expressions, and then later we'll multiply and divide them. All right. So here we're asked to simplify this rational expression, all right, from the previous screen. All right. To simplify this, we need to turn these terms into factors. All right. It's much easier to deal with factors than terms, all right, when we simplify these things, okay? So these trinomials are both factorable, okay? So we can go through trial and error, right, to show that the top can be factored like this and the bottom can be factored like this, okay? So we can actually recognize the top trinomial as a perfect square trinomial, right? It's x plus 4 times x plus 4. And we can use trial and error for this bottom trinomial, right, to get this. Okay? So what we notice next is that the x plus 4 and the x plus 4 cancel. All right? Those cancel with each other. And when things cancel like this, right, when they cancel multiplicatively, what's left behind is a 1, right? There's an invisible 1 right here being multiplied by this thing. All right? When things cancel additively, what's left behind is actually 0. But when they cancel multiplicatively, like this, what's left behind is 1. Okay? So we'll report our final answer as x plus 4 over x plus 7. And we don't need the parentheses anymore. All right? Let's try another one. Here we're asked to simplify x squared minus 9 over x squared plus 4x plus 3. Okay? The top is the difference of squares. All right, so we know how to factor that. All right? And the bottom, we can factor it like this. Okay, we can go through some trial and error to get this. All right, I'm not including the trial and error, all right, for the sake of brevity, but I encourage you to try it out yourself. All right, try to factor this and see if you can get the right answer. All right, and then FOIL it to make sure you did it right. Okay, so with this result, we can see that x plus 3 and x plus 3 cancel, right? So that just leaves us with x minus 3 over x plus 1. All right, so that's our final answer. Next, let's look at multiplying rational expressions. All right, multiply the rational expressions and simplify. All right, so when we multiply this, once again, it's much easier to deal with factors than it is to deal with terms. All right, multiplying these terms by these terms, right, you would have to use the box method and you would get some big ugly expression. All right, so we want to factor these pieces, all right? We want to factor each of these 4 pieces to see what we get, all right, see if anything cancels. All right, so this trinomial up top, right, it can be factored like this, okay? And then down here we can pull out the GCF of 3, right, to factor it like this. This fraction, right, the stuff up top and the stuff on the bottom, that can't be factored. All right, so it's already in its simplest form, so we'll just leave it as is. all right? So here we're multiplying these fractions, all right? Multiplying fractions is easy. I've said it before and I'll say it again. It's easy because all you have to do is multiply the numerators, right, and put it together, and multiply the denominators, put that together, all right? It's a lot harder to add and subtract fractions, right? When you do that, you have to get a common denominator, and that takes a lot of work. All right, so we'll look at that in the next video. But for this video, we're just going to stick with multiplication and division. All right, so we can ease ourselves into this. All right. Let's multiply this fraction and this fraction, all right, to get one big fraction. All right. What happens when we multiply is we just join them together in this big expression, right? Notice that there's parentheses around 2x minus 1, right, because we're multiplying by the entire denominator, or the entire numerator. All right. And same thing for x plus 5. It needs parentheses. Okay? So once we get to this point, we can stop and ask ourselves, all right, what cancels? What can we get rid of? The x plus 5 and the x plus 5 cancel, all right? So what we're left with is x minus 1 times 2x minus 1 over 3 times x plus 6. Okay? So that's our final answer. We can't simplify that any further. Let's try another one. Here, we see that we have 4 trinomials, okay? So these are all factorable, all right? So since they're factorable, that's what we want to do for our first step, all right? We just want to factor each piece, all right? And we get this, okay? So now we're multiplying these fractions, all right? So we'll bring them together in one big fraction, okay? And let's look for stuff that cancels, all right? The y plus 4 and the y plus 4 cancel in red here, and the y plus 3 and y plus 3 cancel in blue, all right? So what we're left with is y plus 6 times y plus 5 over y plus 2 times y plus 4, okay? So that's our final answer, all right? Next, let's move to dividing rational expressions, all right? We're supposed to divide these and then simplify the result, okay? When we divide this fraction by this fraction, all right, that is the same thing as multiplying by the reciprocal of the second fraction, okay? So I'll show you that one more time. This divided by that is the same thing as this multiplied by the reciprocal of that, okay? So we just swapped the numerator and the denominator and turned this into a multiplication problem, right, which we know how to do. All we want to do at this point is factor each of these 4 pieces, all right? So this trinomial, right, we can use the AC method to get this. This down here, this is the difference of squares, so we can factor it like that. This we can use trial and error to factor, and we'll get this, all right? And x squared minus 4, that's a difference of squares, right? So it can be factored like this, okay? So let's multiply these fractions together, right, to get one big fraction. And then let's cancel some stuff, right? X plus 2 cancels with x plus 2, and x plus 1 cancels with x plus 1. All right? So that leaves us with 2x minus 3 times x plus 1 over x minus 1 times x minus 2. And that's our final answer. All right? Let's try one more. This problem is actually pretty interesting. Okay? We're dividing this by that, right? So let's multiply by the reciprocal of that, right? The second fraction. All right. So now this becomes a multiplication problem. All right. So let's see what we can factor. It turns out that all 4 of these expressions, right, can be factored. Okay. So this is what we have after we factor. All right, so next we're going to bring these together in one big fraction. All right, and watch what happens. We can see that the 3x plus 4 cancels with the 3x plus 4, and the 3x minus 4 cancels with the 3x minus 4. All right, but what does that leave us with? It leaves us with this over this. All right, so everything cancels in this problem. Everything cancels. All right, so that leaves us with 1. Okay. I've said it before and I'll say it again, right? If something cancels additively, what's left behind is a 0. And if we cancel multiplicatively, what's left behind is 1. All right? Anything divided by itself is just 1. Okay, so that's our final answer. That does it for this video. Thank you for watching, and like and subscribe.